Angelo, I'm so excited to have you here today.
Michelle, I'm stoked to be here. Thanks for having me.
We are talking protein. We're talking amino acids. We're going to talk about the difference between essential amino acids and non-essential amino acids. And I think quite a bit more because you have a story to share with us. Your life story, I think, would be really interesting. So I think we're going to really just jump in with both feet.
Great. Let's do it.
You said something really awesome in our pre-prep conversation for this episode. You said, I almost want to give people a 6th grade science lesson on amino acids and on protein because we hear the word protein, we hear the word amino acids on podcasts all the time. And I feel much like you feel that people still aren't being able to really visualize what we're talking about and how that relates to them. So I would like to kind of kick us off with, on this very high level, what is a protein and what is an amino acid? And then we'll break it down together throughout the episode.
Awesome. Let's do it. So what is a protein and what is an amino acid? Proteins are these things that are throughout all of nature that have a really big role in making us living creatures. And amino acids are both the building blocks of those proteins, like they're the actual things that make up a protein, and they play this, and sometimes certain types of amino acids play this signaling role. They actually tell the proteins to start building or to rebuild themselves. All right, now let's maybe get even more practical about what that really means. So lots of times when we think about our diets, right, we talk about carbohydrates, fats, and proteins. Those are the 3 macronutrients. There's also micronutrients, like all the different minerals and vitamins in our diet. But of those macronutrients, I think a really important thing to highlight is that protein's really different. It's not really like carbohydrates and fat in a pretty fundamental way. So carbohydrates and fat play this really primary role in energy, meaning we eat carbohydrates and we eat fat. We digest them, and then the main thing that they do is they get converted in this thing in our body called ATP, which is the energy source inside of us that allows us to actually do things. So when I eat carbohydrates or fat, I burn that fuel, I burn that energy in order to beat my heart, to breathe, to walk around, to lift heavy things, to power my brain, etc. So if you think about it like a house, it's kind of like the energy you buy from the electrical grid where they burn coal, or from having solar panels and, getting energy from the sun and bringing it into your house. On the other hand, protein is really different. And this goes back to what I was just saying about, it's like this kind of this thing throughout nature that makes us key to being living creatures. So we and other living creatures are actually made up of proteins. So if you think about it like your house, it's not like the energy you buy to fuel your house. It's like the house is actually made up of wood and nails and metal and glass and all these materials. Those materials have to be made up of smaller things. In our body, those smaller things are proteins. So when you think about all of your vital organs, so your liver, your kidney, your heart, your spleen, etc., things like your skin, your hair, your nails, all of your lean muscle, all of these are actually made up of proteins. So over half of the solid mass in your body is made up of proteins. And the way that proteins work in nature, similar to like a house, is that if you live in that house, if you live in this body, the proteins start to break down. If you walk over the exact same, you have tile maybe in the front entryway of your house, and you walk over it over and over and over again, eventually the grout is going to start to wear out. Maybe the tiles will crack if you drop things on it. Our bodies are the same way. So actually our organs and our skin and our hair and our nails and our muscle, all these things that are made up of these proteins, the little proteins only have a certain, we might call a half-life, like they only last for so long. And then those proteins need to be broken down and rebuilt so you have fresh new proteins. So if I just look at like my skin, it's actually made up of millions of proteins. And I encourage anyone who's listening, look at your arm and be like, wow, that's crazy. It's like these millions of proteins are forming the skin in my arm. Well, each one of those, after a certain amount of time, breaks down and has to be replaced. When the protein inside of that skin breaks down, you basically realize, oh, it's made up of these amino acids. There's these smaller building blocks of the protein called these amino acids. Some of them actually can still be used, like they're still useful, and some of them are too old and they just need to be excreted. So you actually convert them into urea and you pee them out. So part of the protein is broken down and peed out, and part of it is kept to help rebuild a new protein. Like, oh, cool. So that's going to rebuild the skin tissue. Well, that should immediately alarm you. Part of the protein just got peed out. Only some of it is left to help rebuild. Only some of these amino acids are left to rebuild that skin tissue. Where can you get those new amino acids from to help rebuild your skin, rebuild your hair, rebuild your muscle, rebuild your vital organs? That's why you eat protein from another plant or from another animal. Sorry, from another animal or from a plant. When you eat the proteins in chicken breast, or you eat the proteins in egg, or in quinoa, or in legumes, you actually digest those proteins. They get broken down into the individual amino acids. They go into your blood, and then they're supplied throughout the body to rebuild all of these different parts of your body that have to be rebuilt. So going back to the house analogy, that tile in the front entryway gets messed up, and you want to replace it. You actually need to put new grout in. You need to put new tile in, etc. Or if you maybe have a more ambitious vision for your house, or an ambitious vision for your body, like, hey, I want to redo the bathroom, or I really want to cut some fat and add some lean muscle and change my body composition. That is a reason why you would then think about actually remodeling, in the case of the body, with protein. In the house, you're going to have to get different building supplies, etc. So in the body, you actually, if you consume more high quality protein in conjunction with other types of activities, you can actually remodel the body in really specific ways. So hopefully that gives a practical, like you said, sixth grade kind of perspective. I think it's smart. I think it's intelligent. It's not like trying to dumb it down for any of us, but it makes it really real why protein and amino acids are so important for existing.
Exactly. And I think that protein, I almost listed it as being, and explained it as being, it's the cement that holds the house together and the bricks. Like, it's all structural components that hold your body up. And for people, who have been listening to the podcast and who know my deal, it's also really important in people with connective tissue disorders. It's really important with people who don't have that structural stability, because protein's also a major component in our muscle and our joints. And like we were talking about very briefly, neurotransmitters and immune response, which we'll talk about too. But this, it's really interesting, because I think only in recent years has protein been the center of the weight loss conversation, where higher protein diets are, better for weight loss results. Can we talk about the role that protein may play in weight loss in general, and maybe even, like you said, body composition?
Yeah, so there's a few different ways to look at this, so we'll kind of attack it from different angles. If I consume more calories than I need in a day, what will happen? I will actually store those calories. And how will I store those calories? I will store those calories as fat in the body. When you have excess fat in your body, and however you want to define excess, right? Whatever you think is the healthy amount of a body fat percentage, right? Like, that additional fat is storage for later periods in time when maybe I can't find food, I can't find enough calories, and I can live off of that fat. So that's kind of that's the core idea in that context. That said, there's a whole nother component going on in the body around muscle. So if I consume additional protein and additional sources of amino acids, and in most cases, if I combine that with some type of exercise, with resistance training specifically, I will actually put on more muscle. And when I put on more muscle, that would also potentially, that would make me gain more weight potentially, right? So there's two things going on. There's the ability to burn or put on fat, and there's the ability to burn or to put on muscle. And you might be like, well, how do you actually burn muscle? Well, here's the other thing that happens. When you go through a caloric deficit, if you consume less calories than you need in a given day, your body, and you haven't really adjusted for your protein intake, your body now has this situation where it's like, okay, I've got heart tissue that's breaking down. I've got skin tissue that's breaking down. I've got to produce new enzymes and hormones, which are made up of proteins. And it's looking for amino acids, basically fundamentally, to rebuild those proteins. And you're not giving it enough in the diet because you're underfeeding it, right? Not just in the raw calorie intake, but actually in the protein, amino acid intake. The option of the body at that point is it's really singular. The only thing in the body that you can spare from a protein source is your lean muscle. So you will start breaking down muscle to supply the rest of the body with amino acids to help rebuild heart, rebuild enzymes, rebuild hormones, etc. So when you go through a calorie deficit and you lose weight, you're not only burning fat stores, you're potentially also burning muscle stores. And this can become it cannot become, it's even further exacerbated by the point I just made. It's, hey, you're not getting enough protein, amino acids from the diet. On top of that, your body is hungry. Like, it's like, I can't get enough, I can't get enough calories from what I'm getting. So it starts to not use the protein as much that you're even consuming in your diet. Like, if you cut the calories out of your diet and you're still eating some chicken, it's suddenly saying, let's actually not use this chicken to rebuild these proteins. Instead, let's convert it to sugars via this thing called gluconeogenesis. So instead, I can use it as an energy source. So you're no longer using the protein as much as you were before to rebuild all these proteins in your body, and you're breaking down muscle tissue to supply the body with these amino acids. So in that context, I've now cut calories and I'm, quote, losing weight. But what has happened is I'm not just losing fat, I'm also losing muscle. And this, I would say, is the greatest long-term danger of some type of yo-yo dieting. You aggressively cut calories. You're not conscious of the amount of protein intake that you're consuming. You lose fat and you lose muscle at the same time. You do that for a little bit. It gets really hard. It kind of sucks. Or you get to whatever the weight was you wanted on the scale, and then suddenly you go back to the less than ideal behaviors of over consuming calories, etc. But now what happens is you put on more fat. It's much harder to put back on that muscle that you lost than to put back on the fat that you lost. So you do that cycle after cycle after cycle. And after years, what you'll end up with is much less lean muscle and more fat. So if you're trying to achieve, an ideal body composition goal, again, that could be various things. That could be 30% body fat, 20% body fat, but it's going to involve some amount of muscle and tone, I assume. Like that kind of ignorance of protein is going to be a major issue. Now, to dial it in even more,
please.
With a 30%, and this is more current scientific information and research we have over the last few years, a 30% restriction in calories. So I burn about 2,100 calories per day, just doing nothing. But with activity levels, I'm an active guy, it's about like 3,000. It's more like 3,000. If I cut calories by 30%, which would be about 900 calories per day. That's a lot of calories to cut. I mean, if you're like a smaller woman, like that's kind of like insane. But if I were to cut 900 calories and I did that for 7 days, that would get me to about 6,300 calories that I had cut out of the week. I think that's pretty aggressive. I think lots of people think, I want to lose 5 pounds. It's like, no, it's like even trying to lose that much is aggressive in a week. That's a lot less food to eat. With a 30% reduction in calories, what's been shown is that individuals need to consume, younger individuals, it could be even more for elderly or for actually anyone over 40 years old. You need to consume 300% more amino acids, essential amino acids. So basically, you need to consume 3 times the amount of protein that you normally ate while also doing a 30% caloric deficit if you want to maintain net muscle balance. So if you want to only burn, if I wanted to only burn a pound of fat, lose a pound of fat this week using that kind of caloric restriction, I would need to be consuming 3 times the amount of my regular protein or essential amino acid content. Sorry, and we've kind of jumped around, but essential amino acids are the active component of the protein. It's why you eat the protein. It's about half of really high quality protein. That's why you eat it. I need to eat 3 times that amount if I just want to maintain the amount of lean muscle that I currently have. Thus, if someone's long-term sustainable goal is, hey, I want to maintain my muscle, but I want to burn fat, there's no way getting around. You're going to have to cut calories and you're going to have to increase protein intake. Are you willing to increase protein intake that much? That's pretty hardcore. Like that's also a lot more protein, but there's some balance there of cutting calories and increasing protein so that what's happening is you're burning fat and maintaining your muscle. So I think that's the core idea around the actual weight loss process. But I think the bigger picture thing that I would encourage people to try to have in mind is that resting metabolic rate, the idea that I said, hey, I burn about 2,100 calories a day doing nothing, that is based off of also how much lean muscle I have. If I replace a pound of fat in my body with a pound of muscle, I will actually burn more calories per day. If I weigh the exact same weight, but I replace a pound of fat with a pound of muscle, I burn more calories per day because it makes sense, right? Like, even if I'm just lying there and doing nothing, that muscle tissue is made up of proteins, and it requires energy for those proteins to break down and to be rebuilt and to be maintained. If I go and exercise, I have more muscle that I'm having to move around and do things with. It's more energy intensive process to maintain that muscle. So the idea of trying to increase your lean muscle, and this doesn't mean like be a bodybuilder, it just means like have muscle tone. You inherently increase your body's ability to have a higher metabolism, right, and to maintain that metabolism over time, because you're actually burning more calories in everything that you do, whether you're sitting still or you're moving around. So I think those are two really important frames to have in mind when you think about, why does protein matter for sustainable, healthy weight loss?
Absolutely. And what other concerns do you have with people drastically losing muscle on a weight loss journey? Why do you feel, or why is muscle so important outside of just aesthetics? What else does muscle do for us?
So in the context of aging and of undergoing any type of chronic illness or stress, when you get older, it's harder to digest protein. It's harder to utilize those amino acids to stimulate new protein synthesis. So it becomes harder and harder to maintain that lean muscle. Similarly, if you get injured or you get hurt, if you have some kind of illness that lasts an extended amount of time, you also can lose a lot of muscle, because again, your body goes in this stress response where it's not wanting to use the protein in your diet to build and maintain lean muscle. So I think on a fundamental level, you just need to think, hey, I actually need to have in mind, I need to build and maintain lean muscle in general for when things don't go well in life. And it is going to happen. No one is going to avoid illness always. No one is going to completely avoid some type of injury. No one is going to avoid getting older, unless in all these cases you die really young and then like none of this matters. But anyone who's going to keep on going and living, you want to build and maintain this lean muscle because you're going to need it at some time. Okay, well, why are you going to need it at some time? Lean muscle is directly correlated with your ability to maintain activity levels. And that doesn't just mean like going to the gym or going to a yoga class or Pilates. That's like, as you get older, being able to walk, being able to stand up, being able to easily lie down and get up out of a bed, being able to pick up your grandkids. And some people, like, that might seem so far off. It's like, that's, I'm not worried about what's going to happen when I'm in my 80s. Like, if you don't think about and care about these things, you can start to have significant issues relating back to things like you said with connective tissue, right? Way earlier, way younger in life. And so focusing on maintaining the lean muscle, focusing on maintaining things like connective tissue health, et cetera, are going to play a key role in your ability to maintain activity levels. Apart from that, lots of people don't realize, again, going back to metabolism, but specifically sugar, like how we deal with sugar. Muscle absorbs, and most people, over 80% of the sugar that you consume. So the more lean muscle that you have, it plays this key role in regulating blood sugar levels. And just overall, and not to create scare tactics around this, but if you just think about and you look at the data around what is most highly correlated to surviving cancer, to surviving other types of long-term illness, to avoiding falling and having hip fracture, or to recovering from things like hip fracture, to maintaining quality of life later in age, it is lean muscle. Lean muscle is directly correlated. If I have lean muscle, I can survive off the amino acids in that muscle if I can't eat for a while, if I have a disease. It's the thing that allows me to stay active. So it's really like the most important, one of the most important, if not the most important, savings accounts for your body that you can invest in for long-term metabolic health that leads to better cardiovascular health, avoiding injury, maintaining better activity levels, better body composition. I mean, the list just goes on and on.
I also love the to re-emphasize the idea and understanding that muscle is endocrine facing and functioning. So it literally, what you release from muscle is going to be different hormones that are going to interface with the rest of your body that are deeply involved in immunity as well. So it's really interesting about protein that it's this structural basis. There's a smaller structural basis within the structure of what protein is, and that those can create, again, and be the base for these very essential body functions, and that our muscle kind of can create I would call it like an anti-inflammatory system, essentially, by helping our body to release myokines. And that I think is so profound as well. In addition to the fact that, like you said, it's our savings account. It's one of the most important determinants of how someone is going to fare from a mortality risk, from a quality of life perspective. Muscle is one of those most important features. We talked about protein, being different than carbs and fat also, because I think we always think of carbs and fat in this calories in, calories out model. And protein, I just want to, again, reiterate and say that protein is so much more than just the calories that we get from it, because it is like this, it plays roles and functions in the body that so many that we listed. But there's just something really special about protein in that way that I think is worth just, opening up and talking about too. So the structural components of protein are these links of different amino acids. Like we said, we talked about the base of them. Let's differentiate between essential amino acids and non-essential amino acids and why they're given that name. What's the deal?
So there's two primary differences between essential and non-essential amino acids. The one most people are familiar with. The second, most people are not familiar with, and I find it way more interesting and way more compelling in many ways. So the first thing that separates essential amino acids and non-essential amino acids actually lies in the definition of the name, essential. You have to eat them. They are essential. So in dietary protein, let's just say chicken breast, while the chicken itself is not 100% protein, of the part that is protein, part of that protein is made up of essential amino acids. There's 9 of them. And part of it is made up of these non-essential amino acids, the other 11. There's 20 in total. The essential ones you have to eat. So when I digest that protein and the amino acids get released into my bloodstream, the 9, there's no other way to get them. But what's interesting is the other 11, my body can actually synthesize them. It can actually convert the essential amino acids into the non-essential ones. And so that's why, in general, when we talk about things like complete proteins, and oftentimes this is the debate around plant-only based diets versus omnivore diets versus, carnivore diets, is, well, what are the protein sources? Are they complete proteins? And typically, plant proteins are not considered complete. There are exceptions to that. Things like soy, buckwheat, quinoa, that have better profiles of more of the essential amino acids in sufficient amounts can actually be considered complete. Otherwise, you need to combine the different types of plant proteins, like beans and rice.
Beans and rice, the classic. Yeah, exactly.
Yeah, it's like, because some are higher. And that maybe seems surprising to people, but every single protein, a protein in a legume, a protein in a nut, a protein in chicken, a protein in beef, they are not the same. Each one has different combinations of different amino acids. Some are higher in others. And so essential amino acids are these ones that your body basically cannot synthesize. It must consume. Here is, I think, the more provocative and very interesting notion about essential amino acids that people are not familiar with, but has been studied and replicated over and over and over again in studies over the last 20 years. Essential amino acids are not only the ones your bodies cannot make. The essential amino acids play this very important role in protein synthesis. Mm-hmm. So the amount of essential amino acids that you digest and then reach your blood and hit a peak concentration level, like the most amount of essential amino acids you can get in your blood all at once, is directly correlated to stimulating new protein synthesis. And this is not just, say, stimulating what's very common muscle protein synthesis, the idea of telling the body to build new muscle. It's whole body protein synthesis. It tells the body to rebuild skin tissue, to rebuild heart tissue, to rebuild old enzymes, et cetera. It basically throughout the body promotes more new protein synthesis. The more essential amino acids you can get into your blood at once, do that. The non-essential amino acids play no role, zero. They do not play this chemical messenger role. They get used as a raw building material. Maybe if we go back to this idea of the tile in your front entryway, right? So the essential amino acids and the non-essential amino acids will both be materials that get used. They'll get mixed together to create the grout, to create the tile, etc. The essential amino acids play this unique role, though, of actually like being the worker, the guy or the lady that's actually replacing the tile, that's actually building, that's replacing the grout, that's doing all the work there, basically. The essential amino acids have this very unique role in actually being a chemical messenger to tell the body to build new proteins. So it's very distinct and different. Not only can the body not synthesize them, they're not just a building block. They're actually a messenger that can help promote new protein synthesis throughout the body, which makes it much more like a nutraceutical, this kind of very unique provoking of a new body process versus just being a building block material to help replace old proteins.
Because they are directing the action of what the amino acids do, not only being the thing itself, which is very, very interesting. Yeah. Mm-hmm. So I know that there are vegans who listen to this podcast, and I know they're going to say something like, I heard you say you have to have essential amino acids. And their response might be, Angelo, but I'm alive right now, so I obviously don't have to have them. If I don't eat any protein, I'll live. When we say you have to have them, in order for new protein synthesis to take place, what do you mean by that? And how would you respond to that? And I know it's a hard question.
No, I think it's a great question. So I'll just start by saying, I think that you can be vegan and get a sufficient amount of essential amino acids in your diet. So nothing that I'm saying is to try to reject that lifestyle diet decision. I think it's totally a decision you can make. I do think it's harder.
Yeah.
Yeah, and that I would say it's harder and requires more work and more thoughtfulness, and I'll explain why now. So at the most fundamental level, our evolving understanding of the requirements for protein by humans has changed. What is currently considered the recommended daily allowance, as defined by the government, is approximately 0.4 grams of protein per pound of body weight. So if I weigh 100 pounds, that'd be 40 grams of protein per day. If I weigh 150 pounds, that'd be 60 grams of protein. If I weigh 200 pounds, that'd be 80 grams of protein per day. What has become, I think, much more consistently understood, though, throughout various forms of protein, human protein research, is that is really the bare minimum. We actually think the bare minimum might be higher. It's maybe closer to like 0.6 grams of protein per pound of body weight. But let's just say it's the 0.4. When I say bare minimum, that's like organs function. You don't have hair loss. You don't have significant, issues with like enzyme production or hormone production or hair loss or like all these other types of issues. That 0.4 grams of protein, that would be essential. I mean, that would also mean that like those are 0.4 grams of complete proteins. Right. That's why even if you look at some, labels on food products, like collagen, for example, it may say 20 grams of protein, but in the daily percentage, it'll say 0. Why does it say 0%? Because it doesn't count to the 20 grams of protein you're trying to get in a day, because collagen is not a complete protein. Mm-hmm. So similarly, you'll see that with other different types of plant protein sources. So you really need like 40 grams, if you're weighing 100 pounds, just to like not have significant issues. I think that someone who is younger, and also all these figures they're blended for all age populations, but it's also very clear for us that like the older you get, the more protein you need. The more you're trying to lose fat, the more protein you need.
The less protein you eat, probably, as you get older, which is frustrating too, because your stomach acid's lower potentially as time goes on. Your ability to break them down, your interest in protein decreases. So it's very interesting that inverse relationship exists.
Yeah. I mean, it all makes sense as you get older. Historically, we lived to like 50, right? So now we're living much longer. And so like our body's priority to like consume a lot of calories, to stay really strong, to maintain robust skin and hair, to build and maintain muscle. Like, our bodies weren't originally like maybe like programmed, right, to do that. So we have to overcome some things because our environment has changed so much, and it's enabled us now to live to 70, 80, 90, beyond. But going back to this conversation around the amount of protein you want to consume, if you're 20 years old and you're not that active and you eat a whole food diet consisting of all plant sources, and you have low to moderate activity levels, you're not trying to be some like really aggressive, some awesome athlete. I think you can totally hit that 0.4 grams of protein per pound of body weight. I think you could probably even hit the 0.6. You could hit higher levels. So now here's the question. At the higher levels, if you want to live more robustly, and also I would just say that is a person who is not dealing with any underlying like medical issues either. They don't have connective tissue issues. They don't have some kind of chronic illness. They don't have other types of issues going on.
By the way, this person hardly exists, I'm sure, because now like everyone I'm like, does this person live on Earth? I don't know. Like not the country I'm living in, but okay, like everyone has something going on these days. But
I mean, I think they'd be an admirable person. I mean, they sound like a yogi to me or something. They sound like
I
someone
love them. Like, I'm not saying I don't love them, Angelo. I'm just saying I haven't found a lot of them. And I don't know if it's because it's the client pool that I work with and my people, but but anyway, go on with our hypothetical person.
Yeah. And so now let's say, okay, what are like the more ideal amounts of daily protein intake? And this varies a lot. So I'm going to quickly give like general rules. I think that the gram of protein per pound of body weight is a generally good rule for most people that are deeply interested in health. And that could be because you have some type of issues that you're dealing with, and this is not to say it's going to address medical issues, but like you're wanting to lose fat and maintain muscle, or you're wanting to perform better in sports, or you're aging and you're realizing your body's changing and you really want to maintain your health as you age. Any of those types of situations, aiming for more like a gram of protein per pound of body weight of quality, complete proteins is a good goal. So if you weighed 100 pounds, it'd be 100 grams of protein. If you weigh 150 grams, that'd be 150 grams of protein. If you weigh 200 pounds, that would be 200 grams of protein. I think for a lot of people, they're like, whoa, that's a lot of protein.
Yeah.
That's actually like, and I'm like more 200-pound guy. I'm like, wow, 200 grams of protein, that's a lot of protein to eat. And it needs to be complete proteins. So now the question becomes, okay, how can I get that? If you're trying to only get that from plants, here's what comes up. When I evaluate a protein source, there's a few things that come up. One is it complete? Which we've already just talked about to some degree. Like, does it have essential amino acids that make it a complete protein? Number two is, what's the proportion of them? Like, some are better than others. Like, I know that, for example, the proportions of the amino acids in eggs and things like whey protein are some of the best. Like, they're just better than like chicken. And that's not to say chicken isn't good, but they have slightly higher amounts of certain essential amino acids. But the third thing is, how digestible is that protein?
Yeah, that's the question.
And here's another bottom line with plants, is they're simply not as digestible. And I don't mean like when I digest it, like I can't process it or the fiber isn't useful, which is a great part of plants. Like, they have fiber. They have a lot more fiber than some of these other types of food sources. But the actual protein in it, my body cannot break down that protein and get the amino acids out of it to the same degree that it can with animal sources. And that is just what the science has shown. It's not like about how it makes my stomach feel. It's like, I purely cannot use the amino acids in the plants as well.
Is that because of the type of amino acids, or is that because of the actual action on the gut? Is that because it's attached to the fiber along with it? Do you know why?
I believe it's the actual construction of the proteins themselves, and then the way that the proteins are connected to the other types of molecules in the actual plant itself. But I mean, this is like a very rudimentary type of idea, but it does somewhat make sense too when you think about the proteins that you're consuming from animal sources are closer to the types of proteins that make up our body.
Right.
That said, like, why exactly it's been developed that we can actually break down the protein sources from the animals themselves?
It's really important to talk about the digestible, absorbable part of protein, because it's also not only when it comes to essential amino acids, is it like kind of you are what you eat. It's like you are what you break down and then rebuild. So you have to have the capacity to break it down, and you have to have the capacity to rebuild it. Protein is not like this straightforward thing like carbs and fat is, where it's like you said, you get the energy from it, broke it down. It's in the Krebs cycle. We're getting ATP from it. We got it. It's actually a much more like complicated process to turn the protein from an animal into the structural protein of our joints. Like, it's a totally complex process. So you really have to, what I hear you saying is, you have to be so conscious through the foods you're eating to even get those essential amino acids. And most people very naturally, especially if you're eating a vegan diet, are not going to get the amount of essential amino acids that we need just by kind of naturally eating. It does seem to be very intentional because you might have issues with digestion, which if you're listening to this podcast, you probably have some issue with digestion because we talk about digestion issues all the time. You might have some issues with a higher need for those proteins, whether it be from chronic illness, chronic stress, or otherwise. So to get there, it's a little bit of a challenge and a little bit of a hike to get to where you need to be. Is that true? And would you agree with that?
It's more work than it is if you choose lean animal proteins, which could also still be vegetarian.
Yeah.
Honestly, some of the best animal proteins are vegetarian proteins, meaning things that come from dairy or eggs. Those are very high quality.
Eggs have the highest biological value of any protein. Especially egg whites.
And like Greek yogurt is an awesome protein source for people. Potatoes are actually they have a complete protein. They have a complete essential amino acid profile. So obviously very low.
Cool.
Very low in the amount of protein.
But it's a complete gram. And that's what's important. More than collagen even. Exactly.
Yeah. Seriously, potato is a complete protein and collagen is not.
I know it's and also why potatoes have helped like for every population for centuries. If a person was not vegan, let's say a person was an omnivore and they were naturally consuming meat, like maybe once or twice a day, maybe eating eggs and meat once, some combination, would it be possible that they also would not meet their essential amino acid needs naturally, even if you are consuming meat?
So just to define again needs, I'm going to say optimal intake of 1 gram of protein per pound.
We're not talking about not dying. We're talking about for like protein synthesis for the proper and awesome function of your organs and your joints and connective tissue and all this. Yeah.
So I think absolutely. I know lots of people that try to eat well and they're still at maybe 0.6, 0.7 grams of protein per pound of body weight. Most people are not. But here's another point I'll make. That 1 gram of protein per pound of body weight, I gave as a general figure that covers a lot of different things. That's, hey, I'm trying to lose fat, but build muscle. Hey, I'm an aging adult, etc. Hey, I'm maybe trying to be a better performance athlete of some kind. If you combine any of those or make them more extreme, your need for essential amino acid intake becomes even greater. And so I was actually just having this discussion with my wife over the weekend because she tries to eat well. She goes to the gym. She works with a nutritionist. Of course, she doesn't want to hear things from her husband, who's like super into this stuff normally. But she was just asking, she's like, why? She was asking more questions about this. And I was just giving the comparison of, she's in her mid 40s, someone in their mid 40s versus someone who's 25, both females, both trying to go to the gym, both trying to eat these higher macro intakes. The bottom line is that the ability of the 25-year-old to digest the protein, if they're both eating a gram of protein per pound of body weight, to digest that protein, and then for that protein to be utilized, the amino acids in it to stimulate new protein synthesis, it is greatly reduced, unfortunately, for my 45-year-old wife than for the 25-year-old woman that may be training next to her at the gym. And the reason for that is what we discussed a little bit earlier. As we age, we lose the amount of digestive enzyme function to actually break down the proteins. But even more interesting and more provocative is that the amino acids inside of the proteins stimulate less mTOR, which is this key growth mechanism that actually tells the body to build and maintain new muscle, progressively gets worse and worse and worse as we age. So we have clear studies that show that the older you get, it becomes significantly more difficult to build and maintain muscle, not just through diet, but even through resistance training. Like same thing, like going to the gym and trying to do the exercises you did when you're 20 years younger. They literally will not do as much as they used to. That doesn't mean you shouldn't do them. You should still try to do them, but they won't do as much. But the protein also doesn't do as much. So the idea of trying to eat even more protein or supplement with essential amino acids becomes that much more convincing, basically every decade after 30. And here's a really interesting comparison of how essential amino acids work in the body using studies with different age populations and with different protein sources. 30 grams of protein, of beef protein for young, healthy adults will stimulate as much protein synthesis as 70 grams of beef protein. So it's the same type of beef protein, right? 30 grams of beef protein will stimulate as much as 70 grams of beef protein if it is eaten on its own. So the beef protein eaten in isolation stimulates as much muscle protein synthesis, whole body protein synthesis, as the over twice the amount if you consume that beef with broccoli and potatoes and other good things as part of a mixed meal. And in no way am I trying to persuade people to get really weird with your food and have to eat everything in order. I'm just giving the perspective, like, that's really interesting. Like, why is that? The reason for that is what I mentioned earlier, the ability to digest protein and for those essential amino acids to reach peak concentration levels in the blood is what is directly correlated to stimulating new protein synthesis. So when you combine those amino acids with other things, you complicate the digestive process with these other things, you basically get a reduced impact of what the beef is doing. Now, if you're young, if you're doing resistance training, like this issue is less interesting to you. If you're older, if you're 30, 40, 50, 60, 70, 80, the older you get, like, whoa, this is actually like much more provocative to me because my doctor is telling me, or the podcast people are telling me, or all this research is telling me I need to eat more protein, I need to build muscle. How am I going to do it? So it's like, that's really interesting. Now listen to this. That 30 grams of beef protein stimulates less protein synthesis than a whey protein powder. The whey protein powder, in fact, stimulates 3 times as much as the beef. So when you're thinking about day in and day out, hey, I need to consume more protein, it's an interesting thought. Like, wow, if I eat 2 to 3 meals with, like, some meats or cheeses or eggs, etc. in it, like, am I getting enough protein? If I was trying to supplement with a little bit more, what would I supplement with during, like, say, the mid-morning? The whey protein powder will stimulate 3 times as much protein synthesis as the lean beef eaten on its own, rather than trying to eat like one more, beef jerky stick, or trying to eat another chicken breast, or whatever the thing is, or trying to have even one more Greek yogurt. The actual whey protein powder will stimulate more. Why is that? Because the protein powder is even more isolated. It has an even more ideal essential amino acid profile, but really because it's more isolated. Now get this. If you take an essential amino acid supplement that is formulated very specifically according to all the science, it couldn't be any supplement, but one that basically has, we can get into what the type of profile would be. But if you take an ideal essential amino acid supplement, it will stimulate 3 times as much protein synthesis as the whey protein powder.
Wow.
So you're starting to see the essential amino acid supplement is significantly greater impact than trying to eat beef as part of a meal, or eat just a piece of meat, or even just take a protein powder. So now you start to see, like, well, maybe there's ways in which it's not just about me trying to, like, eat that much more protein, or maybe I'm, like, close to the 100 grams of protein per day, but if I'm trying to just add a little bit more, or I might get 0.8 grams of protein per pound of body weight, how could I add a little bit more? The idea of choosing to supplement with something like a protein powder or with an essential amino acid supplement is going to be way more effective than just trying to eat a little bit more meat, especially the older that you get. Another interesting thing I would just say too is, again, going back to the vegan thing, things like essential amino acid supplements, they can absolutely be 100% vegan. There's fermentation processes in which you can produce an essential amino acid supplement that's vegan. So it's another great way to help supplement that diet to hit those higher levels of intake. So I kind of went a little bit beyond your question, which was, well, what if I'm omnivore? Mm-hmm. Am I getting enough protein? What I would say is, if you're combining any of these categories, you're getting older and you're trying to maintain higher activity levels, or you're getting older and you're trying to recover from some type of injury, or you're trying to lose weight, or you're really combining any of these things, I think for sure getting that 1 gram of protein per pound of body weight, but even going above it, assuming you don't dramatically increase your daily caloric intake, is going to really help support your goals that much more.
And I just want to also, take us back to this point, which is that the people listening to my podcast generally have something going on, whether it's some sort of chronic illness, whether it's anxiety and chronic stress. That's just like what we love to talk about on this podcast. So that's my people and the people we love talking with. If we can't absorb because we have chronic stress that causes us to have lower stomach acid, if we can't, basically the process of breaking down and rebuilding protein is very energy dependent and very mechanism dependent. So there's so many ways that the body can be challenged in being able to do that, because it's a pretty hard process to repackage all these proteins and do this. So I think if there's any sort of hack or cheat in ways of taking an essential amino acid supplement, taking a protein powder, some people might actually need that. And I'm putting needs in quotes because, again, the old belief is, what do we need to be alive on Earth? That's like where the RDA, where these protein recommendations are from. Now we have to ask ourselves the question, what do we need to be optimal? And then we have to ask ourselves the further question, what do we need to be optimal when we're starting from a suboptimal place? And it's usually like there's a lot of ground to catch up with for people when it comes to protein because, I have clients, for instance, who have really bad acid reflux. And if they have reflux, you don't feel the interest in eating meat as much, right? And it's a little bit harder to break down because some cases of acid reflux come from too low of stomach acid, some come from too high. So for those people, the barrier to optimal health from the right protein number is higher. So I just want to kind of bring that up, that we're not only talking about people who want to optimize and be athletes, and everyone is entitled to wish to go wherever they want to go, but that there are other barriers for my client population, people listening to this podcast, that actually make these kind of add-ons even more valuable, I feel. So I just wanted to overemphasize that as well.
I mean, I think in so many cases, if you have some kind of underlying health issue that you're trying to get to the heart of and to figure out what's going on, when you understand that proteins are responsible for all your vital organ function, your hormones are literally made of these amino acids, they're proteins, your enzymes. We talked about a little bit earlier, but even like neurotransmitters, so the chemicals in your brain through which you experience emotions, your potential experience of things like fatigue and brain fog, things like that, all the way down to like your body composition and muscle and I can't say everything in your body, but it's remarkably extensive. If one of the first things you look at is not your essential amino acid intake, as it may apply to one of these things, you're overlooking something key. So you don't at all, this is not like a relevant thing only for people who are just trying to like tweak themselves to look that much better, perform that much better, or who were doing great until they reached 45 or 50. And then now they want to things are getting harder. Really for anyone, I think just trying to, you just understand it's like so fundamental to all of these processes. It's a key thing to look at and to try to optimize.
Also, like glutathione, our master antioxidant that we hear about every second of our lives, is literally comprised of 3 amino acids, right? Like the detox process in our body is so protein dependent too. So I think when people are, kicking off these detox processes, they're starting these mold protocols, these parasite cleanses, like we need such a strong basis of protein that's very available to us to be able to even engage in these really like functional medicine practices. Like it's just so important for all of that. And it is so hard to get there without being conscious. So I personally use an amino acid, an essential amino acid supplement I'd love to talk about. I just wish, Angelo, there was one that could meet all of our needs and it was easy for us, so that we didn't have to eat all this protein if we didn't want to and we couldn't get it in. Angelo, what could we do? Tell us, is there any product like this on the market?
Well, I mean, what I will do is I will answer that by describing what is the ideal amino acid formulation and what to look for in a product. And yes, I have a company that makes that, and but I hope all this information comes across truly as educational for folks, and
absolutely
use it as you will. But like, obviously my interest and dedication to the subject and our whole company and working with leading scientists and researchers in this field, it's like, we made the one that follows everything we've been talking about.
Yes, you did.
So, okay. So here's the breakdown. If what you're really interested in is getting the ideal essential amino acid profile specifically for promoting protein synthesis in this whole context that we've been discussing and all the ways that we've been talking about today, there is a formula that has emerged over the last 20 years. And this is from studies sponsored by the NIH, sponsored by NASA, sponsored by independent groups, a lot of different folks. So it's not like it's some secret proprietary thing. Like it's well available research if you go and look for it. This is the amino acid profile that you would want. You would want to have all 9 of the essential amino acids So can't be only 8, like some formulas out there say there are some amino acids that only have 8. Or there could be, you could buy only branch chain amino acids, which is only 3 of the 9. You really want all 9 of the essential amino acids. And then the formula is actually based off of, at the most core level, our human skeletal muscle. So if you do a biopsy of the muscle from your body, what you would find is a proportion of the unique amino acids. Like we were talking about earlier, there's certain amino acids in rice that might be different than the ones that are in chicken. Well, there's unique ones in our muscle. You start with those proportions, and then you increase the amount of leucine to be 40% of the final formula. And then you increase the isoleucine and the valine to maintain their original proportions. And you increase the lysine, because lysine can actually be, it can inhibit the ability for the body to promote new protein synthesis. It basically has a limiting function because it goes slower into the muscle tissue. You increase it. And when you do, you end up with this very ideal formula for promoting protein synthesis. And they've tried, they've come up with this through, again, like, tens and tens, if not 100 studies. And you can find it through various different groups and like with small, slight different tweaks, but this is basically the fundamental formula.
This is the
so
structure,
if you're going to, so if you're going to go out and you're going to look for an amino acid supplement, you definitely want to have that. So the first thing you're going to look for is it can't be a proprietary formula. If you look for an amino acid supplement and it says 5 grams of essential amino acids and then it lists them, but you can't tell, well, how much leucine, how much isoleucine, how much valine, it doesn't tell you, stay away. Like getting the right formula is very important. And someone maybe having way more tryptophan in it or way more some other amino acid in it because it's cheaper for them to make is not ideal. You really want very specific formulas. So make sure it's not proprietary. It tells you exactly how much of each amino acid is in it. It has those proportions that I just described. And if that's kind of too hard to grasp, you can just look at what Kion has. Like if you look at Kion Aminos, you look at those amounts and like you're looking for that basically. And then the next thing I just say is like, you don't need a bunch of other stuff in it. If they have other additional amino acids, things like arginine, which is not a bad thing, but it plays a very different role than, it's a whole nother podcast to have that we could talk about, right?
Yeah.
So it's like, you really just want those 9. You don't need any others. You want them in those proportions. You don't need any other amino acids. You don't need caffeine in it. You don't need really anything else in it. And then very simple additional ingredients. Like, if you're buying an unflavored product that's like capsules, it should basically just be that. If you're going to have some type of flavoring in it, ideally, I advocate for like natural flavoring if possible, and some types of natural sweeteners. And really that's all you need to get the function of what we described today. So that's what I advise people to look for. And I am proud to say that's what Kion makes. So yeah. There you go.
That's incredible. Is there anything else that you think is really important to mention when it comes to protein powders, essential amino acids versus collagen powders, anything like that? I know we covered much of it, but is there any other differentiators that you think are really important for people to know when they're picking any sort of protein supplement or essential amino acid? I know you mentioned BCAAs too. Anything else that we missed?
Yeah, so here's the quick summary I just give on those products without diving too much into the science unless you want to go into them. Collagen is not a complete protein. Don't count it towards your protein goals in that way. If you take collagen, the reason why you're taking it is because it's very high in certain non-essential amino acids, hydroxyproline, proline, and glycine, that play a key role in collagen synthesis in the body. I would say that they're really only worth your time and investment if you have significant issues with the production of collagen in your body. I think that's more related to like specific medical conditions or more advanced age. Like for most people, they're like in their 20s and 30s. I'm like, I think it's a waste of your money. But if you have some other type of specific condition or you're 70 years old, like it makes sense potentially. BCAAs are branch chain amino acids. It's 3 of the essential amino acids. It's not all 9. It's based on earlier science and research without tracing it all. Basically, the scientific community used to think that those 3 alone worked on their own. They don't. We now know that the science has been debunked, like very sufficiently debunked. So
We're
Just
good.
don't waste your money and time on BCAAs. Yes, companies keep selling them. Why are they doing it? Because they can make money doing it. That's why.
And that's
There's like
really it.
older science that they still use and say it's legit, and it's not. So
It
I
was
just wouldn't waste your
like an
money on
obsessive
BCAAs.
pre-workout situation that hasn't died.
And then in terms of protein powders, I think my most highly recommended protein powder to go after, because I think it's the most available and it has the best profile and has the most amount of research and science behind it, is a whey protein isolate.
Yeah.
So whey protein concentrate is the whey that comes from dairy products, but it hasn't been that filtered. So there's still fat and carbs in it to some degree, and there's still some lactose. So it can create upset stomachs for some people. When you go to a whey protein isolate, they strip out virtually all of the carbohydrates and fat and virtually all of the lactose. And so almost everyone I know can digest it easily, can easily tolerate it. It has an ideal essential amino acid profile. It's kind of like the best protein powder. If you're not going to do that, I think some people have had success with like beef protein isolates. It's not quite as good of as a profile. The only thing is, if you start getting into things like bone broth proteins and things like that, like bones don't, you're getting a much less ideal essential amino acid profile. So I wouldn't really go in that direction. If you really want to do plant-based protein powders, I would just say take essential amino acids. Like you can, that's the thing I said about like Kion makes one that's vegan. So it's fermented from plant sources. It's, and it's going to work way better than a plant-based protein powder. So, that'd be kind of like my quick down and dirty general guidelines. And I think,
yeah.
I'd say, why a whey protein isolate versus essential amino acids, which, like, for example, my company, Kion, we make both. They're both two great tools for supporting essential amino acid intake, for supporting protein synthesis. What's the difference between them? Well, a protein powder, for example, Kion's, like, we have unflavored vanilla and chocolate. The unflavored, you can put in anything. You like bake things with it, etc. The vanilla, I mix with like blueberries and like a peanut butter type powder, and it's like this delicious like shake. I give it to my kids and they take it. We can make like ice creams out of it. So it's almost can be used more like a baking type and cooking type material. It's an awesome, more food-like powder, even though it's still a supplement. Whereas the essential amino acids are just way more effective. Like they're just significantly more potent and effective than the protein powder, and they're easier to take. Like I can just take some capsules, or I can shake it up in a drink and drink it while I'm doing some type of athletic activity.
I got to be honest with you. A huge barrier for most people with protein powder is like having to get out a blender situation. The fact that you can mix Kion and water is kind of huge. It's a big deal, to be honest with you.
And it's like, it's super fast and easy. One tip I would give with amino acids is mix them with ice. I think the colder it is, the better, because the amino acids do have, it's almost like why people like really cold milk as a kid. The flavor profile, I think, is much better.
Yeah. So in general, cold is less flavor. So that's why, like, when you're nauseous, you can't like stand the smell of like hot foods, essentially. And why you so that's, if anyone is struggling with like low appetite or restriction, I'm always recommending like colder foods in general. So yeah, the colder, the less flavor comes off of something. So if you don't like the flavor of any, sort of flavoring or anything, yeah, then that's an option. Or get the unflavored one and make it really cold. And then you get like double the benefits. One other question I have for you is, how do you recommend people take them either surrounding workouts? Does it not matter? Would you rather take them on an empty stomach with meals?
Yeah, great question. Fortunately or unfortunately, taking essential amino acids are good almost any time of day, with or without food, before exercise, during exercise, after exercise. So the fundamental response I would give is, what will you actually adhere to? What's most important in health is choosing a behavior and actually sticking to it.
Totally.
So what I advise people to do is, like, when will you actually take it? And actually starting to take something like Kion Aminos every single day is where you're really going to start to experience the benefit. So if you know, like, hey, like first thing in the morning, like that's the time I'm going to shake it up. I'm going to take it first thing in the morning, and it becomes part of I go on a little walk or some other type of exercise, or I take it in the car with me, or like whatever or I take it, whatever the situation is, just find that time. It could also be mid-morning is a great time for people, or mid-afternoon. It can help with little like energy slumps. It doesn't have caffeine, But because we didn't go too much into this, amino acids play such a key role with neurotransmitter function and with the actual energy production at the level of the mitochondria itself, you actually support overall like better energy levels. So, first thing in the morning to replace or with coffee, I take it with coffee first thing in the morning, mid-morning, mid-afternoon, those are all great times. You can take it before bed. It's not like caffeine, so it's not going to keep you up. What's the time of day when you can take it? That said, it's like if you don't really like taking it on its own, you like taking it with food, that's also great. If you take it without food, you're basically stimulating one more bout of muscle protein synthesis throughout the day outside of the times you're eating protein. That said, if you consume it with a meal, whether that meal is low protein and you're basically getting the equivalent of essential amino acids you would be getting from protein, or is even includes protein, because it stimulates the protein synthesis. Like, again, not of the same level that something like resistance exercise does. It's not like lifting weights, but of the same sort. It actually will make it to where you better utilize the protein that you're consuming in the meal. So it increases the efficacy of the protein synthesis that comes from the protein that you're eating itself. So with meals is also good. So what I would just say is like, what's a time of day that you can commit to take it every single day? That's the right time to take it. If you like taking it more than once a day, totally fine. It's been deemed to be safe to be taken up to 20 servings a day. That's a ton. That's like more of like a clinical setting. They did studies for NASA, et cetera. Or, like I have, my father-in-law is about to go through knee surgery. I have him taking like a bunch.
Sending him luck on the surgery.
Yeah. Thank you. Like taking 20 grams. That's like 4 servings twice a day. I try to get him up to 4 times a day if I could, because it will just support that process so much more. But yeah, if you like taking it twice a day, that's great. And then what I would say is make it part of your exercise routine.
Mm-hmm.
Whether you like taking it before, during, or after is fine. There's slightly more benefits if you take it before you exercise, but it's also good if you take it after. Make it part of that routine, and then take it even at times when you don't exercise. Because I think people think like, oh, I take it when I exercise because it kind of maximizes the benefit of combining them. But what's interesting is think about the days when you don't exercise and you're not stimulating new protein synthesis. Consuming this beverage will. So it's a great thing to do on those days when you don't exercise. So I think those would be my basic guidelines. Number one, what's the time of day and a habit you'll actually stick to? And then if you want to take it more than once a day, totally fine. And actually ideal depending on what your goals are. And the third thing is try to also on top of that, pair it with your exercise routine to be something you do with it and or to do even on days when you don't exercise.
I also have my own hack for it, which is I use it in the water that I drink my supplements with, because I know that I'm going to take my supplements. So then I just put it in that water and then I just use it to drink my supplements, because then there's 100% chance I'm going to take my supplements and I'm going to take my Kion. So I've been doing that for years. Yeah. And it's really, again, for people with hypermobility, any connective tissue disorder, this has been like really pivotal for myself, honestly. I was taking capsules and then I was like, it's too many capsules, and just whatever, like you're saying, whatever's easiest. So if you already are taking supplements and you need water to take your supplement, throw it right in the water, take your supplements. That's awesome. You are a wealth of knowledge, Angelo, and I thank you so much for coming on. Where can people, we're going to give links below for even a discount, which you'll have heard about in the beginning of this episode, and you're going to hear about in one more second. But where can people find and learn information about Kion, about amino acids? Where can they purchase? Tell us the Angelo Kion world. Tell us about where we can find you.
I mean, really, I've poured everything into Kion, and that's where all these resources and information are. If you want to learn more, the website's a great resource, getkion.com, getkion.com. We also have a customer service team that's live in person here in our office. You can call and ask more questions, dig in more. But I think that's where I'd start. If you want even more information than that, then yeah, our team would be happy to forward you different research articles, et cetera, where you can learn more.
Thank you so much for coming on, Angelo. And I am actually, I'm going to go drink my amino acids now. I'm very inspired.
Awesome.
I'm like, let me get my connective tissue going. Thank you.
Great. Okay. Thanks, Michelle.